So let's go ahead and consider the following exercise where we have to integrate the following expression by using the change of variables method, or otherwise known as the U method. Now, for the most part, if not always, our choice for U is going to depend on the component that makes this entire expression more complicated. In this case, our 2x minus 1 term. Now, in addition to finding u, we also had to find du, the derivative of u. In this case, the derivative of 2x minus 1 is 2 dx. Now, once we have these two values, once we have u and du, let's go ahead and update our integral. All right, so we're going to have the integral of x times the square root of u times dx, which is du, divided by 2. Now, when it comes to this integral, it either has to be written in terms of x or in terms of u, but not both. Right? So our first challenge lies within rewriting x. And the way that we're going to do that is by using the original substitution that we came up with. Right? Our original substitution was u is equal to 2x minus 1. And from this expression, we can easily rewrite x in terms of u, right? So x is going to be equal to u plus 1 divided by 2. So let's go ahead and introduce this new second alternate form for x into our integral. All right, so we're going to have the integral of x, which is u plus 1 divided by 2 times the square root of u times du divided by 2. Now, as part of this integral, the first thing that I'll go ahead and do to simplify this whole thing, and you'll go ahead and see why in just a moment, is to go ahead and change the square root of u into its exponential form. So this is going to be equal to the integral of u plus 1 divided by 2 times the square root of u, which is e to the 1/2, times du divided by 2. Now, once I have my integral in this form, let's go ahead and just use exponential properties to go ahead and multiply u plus 1 divided by 2 times e to the 1/2. Right? So we're going to have u plus 1 divided by 2 times u to the 1/2. All right, so this is going to be equal to u times e to the 1/2 plus 1 times u to the 1/2. And the 2 is still in the denominator. Right? So u times u to the 1/2 is going to be u to the 3/2. Right? And 1 times u to the 1/2 is just u to 1/2. And we still have the 2 in the denominator. Right? Now, let's just go ahead and substitute this value back into the integral. So we're going to have the integral of u to the 3/2 plus u to the 1/2 divided by 2 times du divided by 2. All right, so the last step before we can evaluate this integral is to go ahead and multiply these two terms together. All right, so the numerator isn't going to change that much. We're still going to have u to the 3/2 plus u to the 1/2, and we're still going to have du. But the denominator, 2 times 2, this is 4. Now, remember that for integrals, an important property is the fact that you can pull out anything that is constant. So in this case, we can go ahead and pull out a 1/4, just like this. And on the inside, we're going to be left with u to the 3 halves plus u to the 1 half du. Right? So once we have the integral at this point, then it just becomes a pretty easy integration problem. Right? We're going to have 1/4 on the outside. The integral of u to the 3 halves is u to the 3 halves plus 1 divided by 3 halves plus 1. The integral of e to the 1 half is e to the 1 half plus 1. And the same thing in the denominator. All right, and don't forget your plus c constant, since we're dealing with an indefinite integral. All right, so let's go ahead and simplify this expression right here. All right, so this is going to be equal to 1/4, which is still on the outside. We're going to have u. 3 halves plus 1 is 5 halves. And then 1 half plus 1, this is going to be 3 halves. And then we still have our plus c. So let's go ahead and keep on simplifying. So we're going to have 1/4. And this is going to be 2u to the 5 halves divided by 5 plus 2u to the 3 halves divided by 3 plus c. Right? Once we're at this step, all we have to do is distribute the 1/4 to each term inside the brackets. Right? So we're going to have 1/4 times our first term, which is going to be 2u to the 5 halves power divided by 20. Right? 1/4 times our second term, this is going to be 2u to the 3 halves power divided by 12. Right? And when you do 1/4 times c, which is a constant, all you get is another number, or in other words, another constant. Right? So let's go ahead and simplify this expression right here. Right? This is going to be equal to u to the 5 halves divided by 10 plus u to the 3 halves divided by 6 plus c. Now, this answer is incomplete. The reason why is because u in the first place is just a substitution, right? So we have to reintroduce the original value for u, and that's going to be our integral, right? So remember from the beginning that the value for u was 2x minus 1, right? So the integral for the entire expression is going to be equal to 2x minus 1 to the 5 halves power divided by 10 plus 2x minus 1 to the 3 halves power divided by 6 plus c.